Screaming through the skies at an unprecedented 540 miles per hour, Germany's Messerschmitt Me 262 ripped through Allied fighters, outpacing them by more than 100 miles per hour. Its arsenal of 4 30mm cannons spat destruction, capable of ripping through the toughest bomber armor with terrifying ease, while its advanced engines allowed it to soar to altitudes where many Allied aircraft gasped for air. The Nazis may have been staring at impending defeat, but this airplane seemed like a sudden miracle from God, the first operational jet fighter. But from the perspective of Allied pilots, it was the devil's work. The appearance of these aircraft over Europe sent shockwaves through Allied ranks. Pilots spoke in hushed tones of phantom fighters that materialized from thin air, unleashed hell, and vanished into the clouds before anyone could react. As the Third Reich teetered on the brink of collapse, German leaders clung desperately to the hope that this cutting-edge creation might yet turn the tide. In the late 1930s, as Europe teetered on the brink of another world war, aircraft designers across the continent were pushing the boundaries of aviation technology. Piston-engine aircraft were approaching their physical limits, and engineers began to explore alternative forms of propulsion. In Germany, a young physicist named Hans von Ohain was working on a revolutionary new type of engine, the turbojet. Von Ohain's work caught the attention of Ernst Heinkel, one of Germany's leading aircraft manufacturers. Heinkel saw the potential of jet propulsion and began secretly developing a jet-powered aircraft. On August 27, 1939, just days before the outbreak of World War II, Heinkel's efforts bore fruit as the HE-178 became the world's first jet aircraft to fly. This breakthrough did not go unnoticed by the German Air Ministry. In 1940, spurred by the potential of jet propulsion and the weaknesses exposed in the Luftwaffe during the Battle of Britain, they issued a specification for a jet-powered fighter aircraft capable of speeds over 600 miles per hour. Among the German aircraft manufacturers who answered the Air Ministry's call was Messerschmitt AG, led by the brilliant but controversial designer Willy Messerschmitt. His team had already produced the Bf-109, one of the most successful fighter aircraft of the war. Even before the requirement was announced, Messerschmitt AG had already been working on their own concept for a jet-powered aircraft, known as Project 1065. This early design envisioned a conventional aircraft with straight wings and a single jet engine. Now, the company would need to evolve its design to meet the new specifications. By 1941, Messerschmitt's team had radically altered the aircraft's configuration. The design now incorporated 2 jet engines, one under each wing, offering increased thrust and improved reliability. This twin-engine layout also allowed for a slimmer fuselage profile, enhancing the aircraft's aerodynamics. These changes would give birth to the revolutionary first Me 262 prototype. The most striking feature of the first Me 262 was its swept wings, a design element that significantly reduced drag at high speeds. The wings incorporated an 18.5-degree sweep and were mounted midway up the fuselage. This sweep angle was carefully chosen as a compromise between high-speed performance and low-speed handling characteristics, essential for an aircraft expected to operate in various combat scenarios. The wings had a span of 41 feet 6 inches and a total area of 234 square feet, providing an aspect ratio of 7.32. This was considerably different from the straight wings of contemporary fighters like the Bf-109, which had an aspect ratio of 6. The aircraft's sleek aerodynamic fuselage measured 34 feet 9 inches in length, with a height of 11 feet 6 inches. Its pointed nose housed the cockpit and was designed to accommodate radar equipment in future versions. The pilot sat under a bubble canopy offering unparalleled 360-degree visibility, a crucial advantage for a fighter aircraft. This was a significant improvement over the more restricted view from the Bf-109's framed canopy. The cockpit boasted advanced features for its time. A gyro gun sight was incorporated to automatically calculate the lead necessary to hit a moving target, making the aircraft a potentially lethal opponent in air-to-air combat. The layout was designed for optimal pilot efficiency, with key instruments and controls placed within easy reach. The control stick was equipped with buttons for firing the guns and jettisoning the canopy in case of emergency. At the heart of the Me-262V1 were its Junkers Jumo 004 turbojet engines mounted in pods under the wings. Each engine was designed to produce 1,980 pounds of thrust, promising speeds of up to 540 miles per hour in level flight, a performance that would far outstrip any Allied fighter of the time. For comparison, the North American P-51 Mustang, one of the fastest Allied fighters, had a top speed of about 440 miles per hour. The Me-262's engines were fed by intakes on either side of the nose, with exhaust exiting at the rear of the engine pods. The intakes were carefully designed to slow down the incoming air to subsonic speeds before it entered the compressor, a crucial feature for efficient jet engine operation. The airframe made extensive use of aluminum alloys to save weight while maintaining structural integrity. The V1 prototype had an empty weight of approximately 8,400 pounds and a maximum takeoff weight of about 14,100 pounds. This gave it a power-to-weight ratio significantly better than any piston-engined fighter of the time, contributing to its exceptional performance. The Me-262's landing gear configuration was equally innovative. It featured a tricycle arrangement with a nose wheel and two main wheels retracting into the fuselage. The main gear retracted inward into the wing roots, while the nose gear retracted forward into the fuselage. This design, unusual for German fighters of the era, was chosen to provide improved visibility during takeoff and landing and enhance ground stability. The layout also kept the jet exhaust farther from the ground, reducing the risk of foreign object damage to the engines during takeoff and landing. The prototype carried four 30mm Mk108 cannons mounted in the nose. These powerful weapons were chosen for their ability to potentially destroy an Allied bomber with just a few well-placed hits. Each Mk108 had a rate of fire of about 650 rounds per minute, and the concentrated firepower of four such cannons was unprecedented in fighter aircraft of the time. Some versions were also designed to carry rockets under the wings, further increasing the aircraft's destructive potential. On April 18, 1941, the Me-262V1 prototype made its maiden flight at Augsburg Airfield. However, due to delays in jet engine development, this initial flight used a conventional Junkers Jumo 210 piston engine mounted in the nose, with two jet engines fitted in the wings for testing purposes only. The test pilot for this historic flight was Fritz Wendel, Messerschmitt's chief test pilot. It wasn't until July 18, 1942, that the Me-262V3 prototype made its first flight powered solely by jet engines, again with Wendel at the controls. While he reported that the aircraft handled well, he noted that it lacked power. This issue would be addressed in subsequent prototypes as more powerful versions of the Jumo 004 engine became available. The testing phase revealed several challenges. The revolutionary nature of jet propulsion presented unfamiliar problems to test pilots and engineers. One significant issue was the slow acceleration of the jet engines, which made takeoffs and landings particularly hazardous. The aircraft's high landing speed, much faster than that of piston-engine fighters, led to the development of a drogue parachute system to aid deceleration during landing. High-speed testing revealed that the Me-262 could reach speeds approaching Mach 0.86. However, pilots encountered control difficulties as the aircraft neared the sound barrier. This led to further refinements, including strengthening of the airframe and improvements to the control surfaces. The testing process also exposed persistent issues with the Jumo 004 engines. They were prone to catching fire and had a short operational life, sometimes lasting only 10 hours before requiring an overhaul. Engineers worked tirelessly to improve the engines, but wartime shortages of high-quality materials meant many of these problems remained unresolved. Despite these challenges, the Me-262 progressed through its testing phase. The lessons learned during testing led to numerous refinements in the design. The wings were reinforced to handle the stresses of high-speed flight, and the control systems were modified to improve handling at transonic speeds. The cockpit layout was also refined based on pilot feedback to improve ergonomics and combat effectiveness. After extensive testing and refinement, the first production models of the Me-262 were delivered to the Luftwaffe in April 1944. These aircraft incorporated all the lessons learned during the prototyping and testing phases, resulting in a fighter that was faster and more heavily armed than anything the Allies had in service at the time. The Me-262 made its combat debut in July 1944, when a single aircraft successfully attacked a British Mosquito reconnaissance plane over Munich. This marked the beginning of a new era in aerial warfare as the world's first operational jet fighter entered the fray. The initial variant, the Me-262A-1A, served as the primary fighter, showcasing the aircraft's revolutionary capabilities. As August 1944 arrived, the Luftwaffe began deploying Me-262s in greater numbers. Simultaneously, Messerschmitt engineers worked to address early technical challenges, particularly focusing on improving the reliability of the UMO 004 engines. These efforts led to the later production of JUMO 004B-4 engines, which gradually extended the operational life from a mere 10 to 25 hours to as much as 50 hours. In September, the Luftwaffe formed its first dedicated Me-262 unit, Kommando Nowotny, under the command of ace pilot Walter Nowotny. Despite the pilot's initial inexperience with jet combat, the unit's Me-262s quickly proved their worth. On October 7, 1944, they demonstrated their potential by shooting down 9 B-24 Liberators in a single engagement without suffering any losses. As combat experience grew, so did the Me-262's versatility. The Me-262A-1AU-3 reconnaissance variant emerged, replacing the nose-mounted guns with cameras for high-speed, high-altitude surveillance missions. This adaptation highlighted the aircraft's potential beyond air-to-air combat. The Me-262's superior speed made it a formidable opponent, allowing German pilots to dictate the terms of engagement. They developed effective tactics, approaching Allied formations in shallow dives, making lightning-fast attacks, and then zooming away before the enemy could react. However, the jets remained vulnerable during takeoff and landing, prompting some units to experiment with rocket-assisted takeoff systems to reduce this risk. By late 1944, the Luftwaffe introduced the Me-262A-2A variant, known as the Sturmvogel, Storm Bird. Optimized for the fighter-bomber role, it featured a strengthened undercarriage to handle increased weight and could carry 2 550-pound bombs under the nose. This adaptation reflected the changing demands of the war as Germany found itself increasingly on the defensive. As 1945 dawned, the Me-262 continued to evolve. Cockpit pressurization was introduced, allowing for more effective high-altitude operations above 26,000 feet. This improvement was crucial for intercepting high-flying Allied bombers and for conducting reconnaissance missions. Additionally, the Me-262B-1, a variant, addressed the need for pilot training by featuring a second cockpit for an instructor. In January 1945, the Luftwaffe formed a special unit, Jagdverband 44, under the command of Adolf Galland. Composed of Germany's most experienced fighter pilots, this elite unit achieved impressive results despite entering the war in its final months, further demonstrating the Me-262's capabilities in skilled hands. As the conflict neared its end, Messerschmitt continued pushing the aircraft's performance envelope. They developed the Me-262B, 1A U-1 night fighter, equipped with FUG-218 Neptune radar, its characteristic antenna array resembling stag's antlers. This variant enabled the interception of Allied bombers in darkness, adding a new dimension to the Me-262's combat capabilities. The final major variant, the Me-262C, was designed to incorporate a rocket engine in the tail for short bursts of extreme speed. Although this model didn't see combat, it represented the ongoing ambition to enhance the Me-262's performance even in the war's closing stages. Throughout its operational history, the Me-262 had a significant impact on Allied air operations. While fuel shortages and vulnerable airfields limited its availability, when operational it proved to be a potent weapon. German pilots claimed 542 Allied aircraft destroyed, although the actual number is debated. Even if lower, the psychological impact on Allied air crews was considerable. These continuous improvements and adaptations demonstrated the Me-262's vast potential, hinting at what might have been possible had the aircraft entered service earlier in the conflict. Despite its late introduction, the Me-262 left an indelible mark on aviation history, setting the stage for the jet age that would follow. Its swept-wing design and pod-mounted engines became standard features of jet aircraft for decades to come. The challenges encountered in its development and operation provided valuable lessons for future jet aircraft designers. After the war, captured Me-262s were extensively studied by the Allied powers. The Soviet Union's MiG-15 and the United States F-86 Sabre, both important fighters of the Korean War era, showed clear influences from the Me-262's design. Today, several Me-262s survive in museums around the world, including the National Air and Space Museum in Washington, D.C., and the German Museum of Technology in Berlin. In recent years, several flying replicas have been built, allowing a new generation to experience the sight and sound of this revolutionary aircraft. The Me-262 represents a pivotal moment in aviation history, marking the transition from the piston engine era to the jet age. Its legacy lives on in every modern jet aircraft, a testament to the ingenuity and foresight of its designers, even as it serves as a reminder of the technological advancements driven by the tragedy of war.